I'm tired, options are few. I'm trying to pray, but where are you? I'm all churched out, hurt and abused. I can't fake what's left to do. Truth is I'm weak, no strength to fight, no tears to cry. Even if I tried, but still my soul refuses to die. One touch will change my life. Take me to the King. I don't have much to bring. My heart's torn in pieces. It's my offering. Lay me at the throne. Leave me there alone to gaze upon your glory and sing to you this song. Please take me to the King. Truth is, it's time to stop playing these games. We need a word for the people's pain. So Lord, speak right now. Let it pour like rain. Oh yeah, we're desperate. We're chasing after you. Oh, no rules, no religion. I've made my decision to run to you, the healer that I need. Take me to the King. Don't have much to bring. My heart's torn to pieces. It's my offering. Lay me at the throne. Leave me there alone to gaze upon your glory and to sing to you this song. Take me to the glory in the way. We keep making mistakes. The glory's not for us, it's all for you. Take me to the King. I don't have much to bring. My heart's torn to pieces. It's my offering. Lay me at the throne. Leave me there. Leave me there alone. I wanna gaze upon your glory. Sing to you. To sing to you this song. Take me to the King. Take me to the King. Take me to the King.
Good morning. I know we had a wonderful night rest. We are again commencing the proceedings for this morning, and I hope we've taken our tea. We are having our tea break now. At 9, we are starting. In case you have not, the tea is still available. We have just about 5 or so minutes to commence proceedings. And if we check our program, it's very clear what we are going to be doing today. We need to also start on time because it's quite a loaded program. the participants all the way, some outside this country and some within the nation, to this event. We saw your outstretched hands yesterday. Lord, we also ask that you lead and guide every deliberation today in the name of Jesus. At the end of it all, the glory shall be ascribed unto your holy name. For in Jesus' mighty name we have prayed. Please, let's be seated. We are having some adjustment in the program. We'll be starting this plenary session on GDC and IFES, but we'll be starting with Dr. Hans Jogen Hoyer, the Secretary General of International Federation for Engineering Education Societies. So may I invite him to the high table? May I invite Dr. Hans Jogen to the high table? Thank you. I'd like to also invite Professor Peter Kilpatrick to the high table as well. I also understand that Professor Jacob is also in the house. Please, we want to also invite him to the high table. We also have, all the way from India, Mr. Saint Hill Kumar. I hope I'm correct. Please, can we invite him also to the high table? We also have Mr. Paul Gilbert. Please come here, invite him also to the high table. Thank you, thank you. So we'll be starting with Dr. Hans Jogen Hoyer, the Secretary General, International Federation for Engineering Education Societies, and also the Executive Secretary, Global Engineering Deans Council, GDC. And he'll be focusing on engineering training for global competitiveness. Engineering training for global competitiveness. Then he will now invite Professor Jacob to take it from there. You're welcome, sir.
Thank you very much. Good morning, everybody. Can you hear me? Good morning. In the background, can you hear me? No. Okay. The people are coming in slowly. My friend is okay. I'm very delighted that two very close friends and colleagues are here to join, and as a result, this is both Professor Jacob and Paul Gilbert. And as a result, I will reduce my presentation, giving them an opportunity to share their very creative work with you. So I want to simply focus more specifically. I have an extensive PowerPoint that, of course, is with our wonderful friend Christian that he can share with you. And I'd like to give me your card, your business card, so I can also personally send it to you. It'd be a pleasure to share that. So my presentation will be quite reduced. And basically, in essence, because some of the themes we've been in this under discussion over the last couple of days, I basically want to re-emphasize basically that this community here in Nigeria, in Africa, you're very much part of a global community. And that global community is daily, continually shrinking, coming closer together. And the fundamental role that I deal with is to basically help link the energies, the intellect, the personalities of the engineering community globally, continually throughout the 6 continents. So I'm just going to give you very briefly in terms of, you've heard a lot not only about the GDC, and of course our president, chair, Peter Kilpatrick is here with us. Also, we've talked about IFES and some related activities, and we have several Nigerian colleagues, and some of which are here, that have been engaged in IFES and some of our global activities. And I just want to very briefly share that with you and make you aware. Another fundamental interest that we have, both Funso Falade and Peter Kilpatrick, is to motivate you, encourage you, inform you about other global spaces where serious people like yourselves are coming together. It's very interesting. Last night, right after our dinner, beautiful, and again, many thanks for the banquet last night, a group of about 10, 12, both industry leaders and academic leaders met to continue the discussions here in terms of how to implement some of the issues as a next step in terms of bringing together industry and academia, and then, of course, work with government. And I was engaged and listening and learning with one of the most really fruitful, exciting dialogues. And what went to me is the kind of issues that you here in Nigeria face. I'm sure friends and colleagues face very similar issues in Kenya and South Africa and others, and there are other spaces. And this is one of the very critical things that the African Engineering Deans Council is facilitating, is breaking the barriers, the isolation of serious professionals in their respective societies, and link it to colleagues in neighboring countries and the world, continually learning from each other. Okay, I guess, okay, I need to say next. That's, we've agreed on that. Okay. What I just want to share for the few minutes that I have in terms of who we are. Next, please. I have the privilege of representing the International Federation of Engineering Education Societies. Africa has been deeply engaged in that organization that was formed about 11 years ago. And your good colleague and friend, Funso Falade, who is president of the AE, has been a very critical, dynamic partner engaged in linking the global community. As you can see, it's up there, what we try to be is a collective voice and change agent for achieving excellence, relevance, and equity and diversity across the globe. And without going to the details of my PowerPoint, next please. One of the critical things, because also here we are present, I've been in dialogue with several professors who are not deans or not vice chancellors and what have you. I want to make you aware of other networks outside of Nigeria, outside of Africa, and ask you to seriously think and join us here. And a very interesting institution that we started called Aedc, in which we provide workshops on many issues related to capacity building for faculty members, okay? Without going the details here, and I'm very happy. I've had some very interesting discussions with several of you about that. I'd like to invite particularly professors, certainly deans are very much welcome and chancellors, but certainly other professionals in the academic community to join us. The next one, please, is just to give you a sense, very important relationships we've built with our friends UNESCO. You had the chance to meet our good friend Rovani yesterday. Certainly the Organization of American States, we worked very closely with the Latin American or the Americas per se, and then of course also with the World Bank. And at least we were hoping we have a representative of the World Bank with which we have quite continued connections per se. Next, please. This gives you a sense in terms of the global community. You are very much, Nigeria, Ghana, the other African countries represented here, very much part of a global community that is increasingly seeing the value, the specific contributions that having dialogue, finding ways to collaborate with your global colleagues makes sense. Next one, please. I'm very proud of a strong relationship that we have built, for example, one specifically with Tsinghua University in Beijing. I happen to be also on the governing board of that and the UNESCO partnership working with Tsinghua, where we have provided capacity building workshops the last 8 years for its faculty, for deans. And we are also doing this in some other countries, particularly Latin America. And we were certainly very interested to explore and dialogue with you, carrying out certain capacity building initiatives, workshops in the African context. Next, please. I'm very happy in terms of the presence and your intellectual and encouragement and the presence of students here. I've been very much involved and helped catalyze this global organization of student leaders over the last 11 years. And you saw the representatives here, your students from Nigeria primarily, the student vice president from Kenya was present here, and there's a whole leadership structure doing really creative work, linking the new generation of engineering leaders at a global, not only at a country and a regional, but a global level. And we are very delighted that, that Africa has taken its first step in that, and we certainly want to work on that. And that's a very strategic importance, as several of you have said. We wouldn't be here if there weren't students. We are here because of our students, obviously, and the deep commitment and engagement that we have. So increasing the dialogue of students with leaders such as yourself and breaking some of the cultural and emotional barriers and what have you, I've just seen some amazing progress. Next, please. Of course, Peter, as president, he'll probably make some remarks per se, but it's been an incredibly exciting journey to work with friends here and colleagues in Africa and throughout the world in the formation of the Global Engineering Deans Council. And Peter and I are just very honored to have the privilege to be partners with you, to work with you. I was at the foundation of the African Engineering Deans Council 4 years ago in Nigeria here. And the leadership, of course, of Professor Obiazi and others was very critical. And when we see the results here, the work, us coming together, the quality of the program, the quality of the interactions and open of dialogue, I think is quite impressive. And the GEDC, we have a deep commitment and building on hopefully specifically action-oriented points that come out of this meeting will continue to accompany you, to work with you, and not only in terms of the Nigerian and African context, but beyond that. Next, please. Just to give you a sense of some of the strategic directions of the GEDC. Next, please, the GEDC membership. We will be celebrating, and Peter and other good colleagues are already beginning to most effectively celebrate the 10th anniversary of GEDC next year in the United States at the University of Albuquerque here. And it's a joy for me to continually meet and connect engineering deans and engineering leaders throughout the world to begin to work together, to find avenues for win-win collaborations. And one of the fundamental things to me is I'm seeing the community here in Nigeria, as I see the African community, and as people know each other and work each other, what is really, from my sense, is not only looking at the intellectual strategic issues, but the tremendous opportunity that I'm seeing and what's happening is really building trust among serious professionals, building trust. That people can openly discuss and share problems, things that work and that do not work, for example. And I've seen that to be a key element in the successful building of partnerships, not only within a country, within a particular society of similar cultural values, but at a global level. Next, please. We are very proud of, and this has been in evolution over the last couple of years through a good friend from Australia, we just really had an absolutely fabulous, the first really, I think one of the most creative spaces I would call in terms of creating a dialogue between deans and the business world, and academia and the global enterprise. We just met in Paris, close to about 70 individuals, one of the most creative environments to really explore the issues of how these two worlds come together in a more meaningful way. And certainly the dialogue that I've seen here and emerging in some of the follow-up actions that I saw, particularly last night as we stayed there together until about midnight, continuing to discuss that, is very exciting. There's some very serious commitment here that I see in Nigeria to really move this forward. Next, please. I'm very pleased, and you'll have the chance to meet my very close friend, Professor Jakob Hasteke from Morgan State University. We have been supporting something we call the GDC Airbus Diversity Award, which we're in the process of selecting this year's finalists to be decided in Canada. and Jakob was last year's winner. And you'll see, not only has he achieved this reward, but some of the work that he is carrying out in the African context is just really, just breathtaking. I'm just very, very happy and very proud. So next year, I'd like to see very much even more applicants for this diversity award from Nigeria, from throughout Africa per se. The next, please, simply, this is the current leadership here. Of course, you know Peter. The next one, please, join the EDC. Next, please. A critical mission and purpose that Hans has. I want you to think seriously, the deans and vice chancellors, to consider becoming a member of the GEDC, of the Global Engineering Deans Council. You're engaged in the Nigerian Deans Council, you're engaged, many of you, in the African Engineering Deans Council. My challenge to you and the opportunity I want to provide, and I've had conversations with many of you, is to invite you to seriously consider joining that organization, become part in an active and a creative global community that I know you can contribute to. And we have several very, very good friends, Henry and several others that are members of that. Just keep going. I'm looking at the time to be realistically, just keep going. Next. I'm not going to share with you the history of the shifts in globalization that we have, and I'm very happy to share my PowerPoint presentation with those of you who are interested. Of course, our friend Christian has those available here. So just keep going. Next, please. Some of the data that I'm sharing you was also shared by Rovani in terms of the impact of the IT revolution that we're working in nowadays. Keep going. Next. For example, I mean, to me, one of the fascinating trends that we are seeing, look at shifts in the audience globalization. China will soon become the #1 English-speaking country in the world. India's top 25% IQs equals the total population of North America. Just think about that. The other one, look at this one. Average student today is expected to have 10 to 14 jobs, and the top 10 jobs in most demand today did not even exist 10 years ago. I mean, look at the implication that has in terms of our world per se. Again, just next, please. Amount of new technological information is doubling every 2 years. We're living, all of us, in this revolution, and our capacity to adapt, to learn, as faculty, as academic leaders, is quite astonishing. And next, please. Keep going, please. For example, go back to the one. Currently, we are preparing students for jobs that don't yet exist, to use technologies that have not yet been invented in order to solve problems that we don't yet know exist. Quite mind-boggling, isn't it, when you think about that? Next, please. Next, please. I've articulated quite a number of challenges. I think many of you are aware of that, and we simply don't have the time to go over that. Next, please. This one I do want to read here. In the spirit of honoring traditions, universities hang on to past practices, imperiling their future. Obviously, that's a critical question for all of us here representing university. Do we indeed hang on to past practices, thereby imperiling our future? That's a critical discussion, but I'm sure many of you are engaged in, per se. Next one, please. The whole question of e-learning and versus classroom is a revolutionary discussion and dynamic at a global level. Continue, please. Next. Challenge number 5, global learning. Open global market for content, talent, and competencies. Expertise can be exported wherever the demand exists. No geographical boundaries with regards to talent acquisition. I think these are all issues that I think we're all familiar with. Next, please. Keep going. The future of learning. Keep going. Next. 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 Just a discussion about the future of engineering, the new revolutionary developments that are occurring, will be going on in the profession. Next, please. The whole discussions around new technologies. Keep going. Next. 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 Okay, let me just stop right here. I want to take this final opportunity and moment is that Peter and I and a whole team of just first-rate friends and colleagues in Canada, particularly McMaster University, our host, the Dean Ishwa Puri, he himself and his team is working 24/7 to prepare what I think will be one of the most outstanding, creative, out-of-the-box, I think, GDC conferences coming up in a very special place on the globe, Niagara Falls in Canada. And I really want to plant this seed and for you to think actively to join us on October 11th to 13th, to join us in this conference here and join many, many serious, committed leaders such as yourselves in that. So this is a very special plea, a special personal invitation. Get in touch with me and Peter while we're here if you have any questions about that. These are some of the critical issues we're discussing, focusing on energy, bioinnovation, and smart systems, all critical issues. Next, please. The other hat that I wear is as the Secretary General of IFES. We've mentioned this many times, and have our global conference in Kuala Lumpur. And several of you I've talked to have been in past WEF's IFES conferences, and I'd like very much for you to encourage your faculty, but also your student. A very critical component we have is the Global Student Forum, where students, engineering students from all over the world are with us here. So I want to raise your consciousness about that. Next, please. There is a Dean's Conference I'm working closely with a Latin American context coming up in September. Next, please. Very, very privileged to work with dynamic leaders and partners such as Paul Gilbert, who you'll meet in a few minutes, that are supporting both the work of the GDC and IFES per se, and very critical, that dialogue, and deepening the whole question, how do we find win-wins between the academic world and the corporate world here? And we have some outstanding partners here. Next, please. In conclusion, education is what remains after one has forgotten everything he or she has learned. Next. It is not the strongest of the species that survive, nor the most intelligent, but rather the one most responsive to change. Just think about that. So I leave with these thoughts. Thank you again for your wonderful hospitality, the friendship, giving me the opportunity. It gives me a pleasure now don't go away, my friend. This is my good friend, our recipient of the GDC Airbus Diversity Award, and one of the most creative professionals I have the privilege to learn from, to be in touch with. And also, it's a nice thing, he happens to be a very good friend.
Thank you. All right. Good morning. It's a pleasure for me to be here. I'm sorry that I have to do my presentation out of order because I have a flight to catch at 1:30, so I will have to finish my presentation. But like Hans said, the slides will be available for everybody to see, and feel free to contact me because my information is there. My talk is engaging and empowering engineering students, and the key part is empowering, and the question is, how can we use engineering education to empower our students so that they become job creators instead of job seekers, like your former president indicated yesterday? Here's an outline of my presentation. I'm going to show what we've done in the US and in Ethiopia, but also focus on what kind of impact are we getting, and it takes time. This is work that I started 7 years ago, and after 7 years, I'm finally seeing some real positive solutions. So the key is keep going at it. Nothing will happen in 1 year or 2 years or even 5 years. And as long as you don't give up, you'll get some good results. Morgan State, we're in Baltimore, Maryland, a historically black college, about 8,000 students, 1,100 in engineering, and we have programs from bachelor's all the way to PhD. So what is experimental centric pedagogy? This area we started back in 2006. I had a colleague from RPI, and the key is, how do we teach students who have varying learning styles? Because everybody does not learn using the same method. And the key is, we want students to learn at their own pace, using their own environments, but for engineering, both inside and outside of the classroom. The problem with teaching engineering is we expect all the things to happen in the lab, and once the lab is closed, students don't have access to the technology. So this amazing technology that my colleague developed in 2006, and we got an NSF grant in 2008. What you're seeing on the left is what we used earlier. It cost about $5,000 to set up one system. And we were able to take that $5,000 set of equipment and compress it to a small device that you can see that is circled, and it costs about $250. So we went from $5,000 to $250, from equipment that you cannot take out of the lab to an equipment that any student can pick with them and take at home and use at home. So it's really an amazing technology. We were fortunate to use it since 2008. And now we have 2 versions which are even cheaper. Next slide, please, next slide. You can see that we have commercial versions now. So this has created a market. So my colleague did not start this work to create a company. He just started to help his students, and because of that, several companies have started producing it. And now we have a $50 version, a $250 version, so everybody's using it. And we're using it not only to help our students, I've also used it to teach classes completely online. So now I can teach my electrical and computer engineering classes from anywhere at any time. All I have to do is just send this board to my students. They can do all the labs. And I've shown that from 2011 to 2014, we've done some work. And what you're seeing in the charts is, the green chart is the online students, and the red and the blue are my regular students. And you can see that when you look at exams, class performance, everything, they perform at the same rate as every other student. So at Morgan and at historically black colleges, because of the work that I've done, we received the grant. Next slide, please, next slide. A $3.8 million grant to take the work that I did in my university and expand it to 13 other institutions. And of course, at the same time that I was doing that in the USA, I was also taking it to my home country of Ethiopia, trying to see how they can use it. So I was expanding this work in the US. I was also doing the work in Ethiopia. Next slide, please. And what we've done in the US, next slide. Next slide. So in the US, we started using it for a few years, and we asked students, what do you prefer? And you can see that using this type of technology, 85% said we like it, and the lowest ranking was lecture. So we, as instructors in engineering, we should stop lecturing a lot and focus more on engaging our students, because the students are telling us, we are tired of your old lectures, and they want us to use technology, they want us to engage them. Next slide, please. Once again, this technology is helping the students. They're thinking that it's going to help their professional abilities. It helps them work collaboratively, because now they do work inside and outside of the classroom. And also, look at the last step. 71% said that it helps them develop self-direction and self-responsibility, which is what we need in our engineering students. We want them to engage in lifelong learning, because after graduation, like Dr. Hoyer said, they will have 10 to 14 jobs, so they will have to learn new skills. And this type of technology allows them to learn new skills on the go. Next slide. So what we've done in Ethiopia, let me go to the next slide, please. So this is, once again, it's a 7-year collaboration, and I'm hoping that this kind of work we can do all over Africa to help our students in different universities. Next slide. So we started in 2010, 2013, where I got a grant from the US to give away 100 mobile studio boards. So we gave 100 of those boards and we gave that to 5 universities. And then in 2015, I got another grant to give another 100. So we had 200 of these boards. Now, if we looked at the old approach and if you thought that each one of them cost $5,000, you can see that the monetary value that this 200 boards is helping the universities. And we have universities who are advanced and some who are starting up, and they're using it for different applications. Those who are advanced, who have equipment in their institutions, they're using it to engage their graduating seniors to work on their capstone design. Those universities in the countryside that are new have no equipment at all, and they're using this equipment to teach their labs on a day-to-day basis. Next slide. So what we did in Ethiopia is we engaged in capacity building. We conducted several workshops. I did 3 years of workshops back to back. And the good news now is when I go to Ethiopia now, I have colleagues within Ethiopia who help me with the workshops because we have enough people trained among 5 universities to do the hands-on. So now I mainly go over the big view, and then the local universities are helping each other, which is really nice. And these are, next slide please, these are the kind of projects that students are doing. Instead of focusing on theory now, students are engaged in hands-on, real projects, building a solar inverter for a water pump, designing a wireless health monitoring systems. These same students in the previous years used to only do simulation and theoretical work because there was no lab equipment for them to engage in this type of projects. But now with this board, they can take it at home for the whole semester. It's like they have their own lab kit, and by doing that, they are really designing amazing projects, which is really encouraging. In other institutions in the countryside, they have such a lack of equipment that they have 20 students for every lab station. So think about doing a lab with 20 students at a station. So here's how they teach a lab in some countryside in Ethiopia. What you see, next slide please. What you see on the left, on your left, is the teacher doing a demonstration of the lab. So they don't actually do a lab. The teacher will walk in, they will see a demonstration, they'll take notes, and that's the end of the lab. And hopefully after graduation, they have learned something, and hopefully they will learn on the job. On the right side, after we gave them the boards, now students are taking the boards at home. They're doing the labs in groups of 3 or 4 or sometimes 5. So by using this technology, we are helping them, and now the universities, instead of buying the $5,000 equipment, they are investing in this small-scale portable equipment, and it's really changing the way we teach engineering. One of the things that really gives me joy, next slide, is since 2010, I've been telling my students and the faculty in Ethiopia, why do we always have to import products from the USA or from anywhere else in the world? Why couldn't you guys design it? Because I told them that this board was designed by 1 professor and 1 graduate student. So after 7 years, I'm happy to see that my students in Ethiopia have designed their own board, wrote their own software. Of course, it's not as small as the commercial version, but now this is what they have. And the plan now is I'm engaging them. I'm talking to the president of that institution. We are going to work with the local manufacturing company so that we can commercialize this for the local market. And that's the challenge that I gave to Covenant, and I told them it took us 6 years to do it. Hopefully you guys with new technology, you can do it in less time. And that's the hope. Finally, the other project that I'm engaged in is called aquaponics. This is another interesting project where multidisciplinary students from electrical engineering, computer engineering, agriculture engineering are engaged in a project called aquaponics, where they use fish, and by using the water from the fish, they're growing plants without any soil. And that's an amazing technology. This is very popular in the US. I help them by using the latest technology to improve the efficiency. So remember, I did not teach them aquaponics. I learned about aquaponics when I came to Ethiopia. I didn't know about it in the USA. But once I saw what problems they had, I helped them with the technology. And now what we're doing, next slide please. What we're doing in Ethiopia is we've taken this aquaponics project, and now the university, using the new technology, has a huge aquaponics pond, which is the size of a swimming pool, where they have 5,000 fish, and now they're selling the fish, they're growing vegetables, as you can see, and they're making $50 to $80 million a year of income to the university, because fish is very expensive in Ethiopia. I'm sure it's the same case in Nigeria. So they're selling the fish, they're selling organic cabbage, organic spinach, all vegetables. The next challenge I give to the students is, this is a large scale. Can we do a small scale so that we can put this in every farmer's house? Because I'm sure every time you hear about Ethiopia, there is a drought, and when there's no rain, the farmers don't have any other source of income. So what we've done now is we've taken the large scale, and what you see on the right side is we've built a small scale portable system that takes maybe 5 meters by 5 meters, and on the left is the design that was done by the students. Once again, our vision is to commercialize this so that the students in Ethiopia can design this, package it, and then you can sell that to every farmer. And the government said they actually will buy this, because once you put the water in, 90% of the water is being circulated all the time. This is all self-sustained, runs on solar energy. The students are engaged, and I'm hoping that eventually the students who graduate will start a business. So now I'm showing them 2 or 3 different ways of starting a business and engaging with their community and helping the community. So I'm hoping that in a year or 2, this will be a commercial version where you see all the things they built locally. It's all plastic materials. The key part is what's on the left, the hardware and the software. All of that is made in China, very inexpensive. The key part is they have to write the software and they have to program it, and that's the key part that we're going to market. This is it. So my vision is, we envision universities in Africa working together and engaging universities in the US, and we can create this collaboration. My hope is to work with Global Engineering Deans Council, Aedc, to keep going with this project, and hopefully in the next 5 years we will have some more outstanding results. Thank you for your time, and the slides are available for everybody to see.
So what have you heard about so far this morning? You heard from Jakob how to create engaged student learners who are entrepreneurs. You're going to hear from Paul Gilbert in just a few moments how to create engaged student learners who are entrepreneurs. And then you're going to hear from Senthil and M. Tudor about creating engaged student learners who are entrepreneurs. So there's a theme here, and I hope you're picking up on that, because I think it's very important. And there's a little bit of irony here that these people who know it all are lecturing to you rather than engaging you with project-based learning in this auditorium. So I'm going to try to, I guess, keep the conversation very simple, so maybe there's even a little bit of time for you to get engaged after you've learned a little bit, so we can have a conversation. But I was asked to speak on entrepreneurship for students, and how do you train for entrepreneurship. And the only thing I know is my own experience, so I'm going to tell you a case study from the University of Notre Dame, where I'm the Dean of Engineering. And this is a master's program. Could you advance the next slide? This is a master's degree program in STEM entrepreneurship. So the only students who can go into this master's program are students who have bachelor's degrees in a STEM discipline. It's the first multidisciplinary graduate program in the history of my university. We're in our 9th academic year. We have about 250 alumni. It's the only academic program at our incubator, Innovation Park at Notre Dame, and it combines innovation, technology, business, and 3 deans were involved in putting it together. Our 2017, next slide. Our 2017 class is double the size of our original class. We're at about 40 students. We have students from a number of very elite universities in the United States, so we're beginning to attract some real national and even international attention. Students from Ireland, Hungary at the bottom, that's the Poznan University. We include customer validation and rapid prototyping in the degree program. Next slide, please. One thing I'm very proud of is we're 30+% women. We're 30+% international, and in the US we're 10 to 15% underrepresented minorities, and those numbers are growing. So it's very important to us that this be a really diverse student body from all over the world, representing all socioeconomic groups in the United States. Next slide. So a little bit about the curriculum. It's pretty simple. And I want to kind of zoom in on what the most important part of the curriculum is. So we do some financial modeling. We talk about how you launch a business. What are all the elements you have to have in place in terms of funding, in terms of chief executive status, chief financial officer. How do you do design thinking to come up with human-centered products? Business model canvas, which is becoming a standard tool for how you think about launching a business, and then all the business fundamentals as well as data analytics. We do a capstone thesis where the student takes a business idea and commercializes it, or takes an industry product, a product or idea, and does what we call intrapreneurship. So innovating from within the company rather than starting your own company. And then there's some technical electives. So the business model canvas is very simple. You can go look it up online. But if you walk through every one of these questions carefully and you really think about it, this answers a lot of what you need to be really thinking about to start a new business. So I guess one of my messages to you here is that entrepreneurship is teachable. And if you have the right person, and I'm going to say a few words about that on the next slide, that has these soft skills. And I want to kind of zoom in on this slide and say, these are not soft skills. These are the hardest of hard skills. But for some reason, they're called soft skills. And what I find fascinating is that Covenant University has most of these as core values of the university. So the soft skill of diligence, what we call in the US grit, and I would characterize that as a willingness and an ability to fail. So you have to be willing and able to fail and then get back up and keep going. And you really have to have that almost existentially to be a really great entrepreneur, because entrepreneurs fail a lot. Intrinsic motivation, I think this is really important. You have to have what we call the fire in the belly. Accountability, self-sacrifice, magnanimity, temperance, fortitude, these are virtues. Ability to communicate and lead, and a relentless pursuit of excellence. I've always seen that in entrepreneurs. They're always pushing to be excellent. Next slide. Our capstone theses started out as research projects that our professors gave, that they were projects that they had written an invention disclosure on or a patent idea, and we were going to see if we can help them commercialize it. We quickly realized after a few years that we weren't going to get enough ideas out of our faculty that were really good. So we went to industry, that's the green bar, and then at the top you have founder ideas. So what we're finding is the students are coming with their own ideas to commercialize, and these are actually some of our most successful projects. So I expect to see that little light blue thing at the top grow over time, and we'll have more and more student founders. Next slide. And these are some of the projects. A lot of them are healthcare related. Many of them are industry sponsor ideas from small startup companies. But we've really had some great success with this. Next slide. So something about the industry projects. One of the things we're focusing on here at this conference is how do we enhance industry academic collaboration. So the industry projects really critically enhance the student learning experience, and it forges new faculty-industry relationships. So any way that you can get a small, medium, or large enterprise embedded in your university, either as a professor of the practice, transferring technology to your students in an entrepreneurship course, or sponsoring capstone design projects, or even freshman design projects in your coursework, any way that you can get industry people embedded in your university is going to increase the dialogue between industry and university, and it's going to enhance what you do at the university. It's going to make it more practical, more relevant. Your students are going to have skills that are more directly related to what industry needs. Any way you can do that, I think, is a good thing. We also get sponsorship fees from the industry. I put this slide up here about innovation ecosystem, but in reflecting on it, this is all the stuff that Michael Fabarode talked about yesterday afternoon. So I'm going to go to the next slide. Placement, 15% of our students are going into startups or starting up their own company. About 28% are going into technical and management consulting, about half are going into industry verticals, and about 11% are pursuing advanced degrees. Next slide. And these are some of the, let me say a little bit about, okay. This is Will McLeod. No, that's okay. These are some of the companies we place up. Next slide. Next slide. There we go. So Will McLeod was one of our first alumni, and he's an impressive character. He started 3 companies now. He's got 6 patents. He's listed in Forbes 30 under 30. He just got the right stuff. And guess what? His GPA as an undergraduate was a 2.6. So no one would have picked him to be this brilliant, entrepreneur, but that's exactly what he is. So you should never judge a student based on their GPA. You know, it may be they simply haven't found the environment in which they're internally motivated. Next slide. Dustin Mix, fantastic young man, started a company called Engineering to Empower, which is a social entrepreneurship company that's building sustainable homes in Haiti in the wake of the earthquake of 2010. Just a fantastic individual. By the way, all the homes he built are zero damage post-Hurricane Matthew. So he's a civil engineer, he's doing it right. Just a wonderful guy. Next slide. Ashley Kalanauskas, tremendous woman. She co-founded Torigen Pharmaceuticals, which looks like it's going to take off in terms of veterinary care. She's now working with the Yukon Technology Incubator Company. And all of this would not have been possible without, next slide, my colleague David Murphy, who's the director of Esteem. He was the president and CEO of Better World Books. Maybe you've heard of Better World Books. It's a B Corp. They do about $80 million now in terms of annual revenue. And Better World Books has been central in bringing books to Africa. So they've sent over $23 million worth of books to Africa in the Books for Africa program. And he also works in a number of other social entrepreneurship venues, but just a wonderful individual. And my last slide is that I think the key ingredient is people. And more importantly, it's people that have those soft skills that are not soft, people who interact with other people and who know how to seek out mentoring and how to get the interaction that they need to have those skills that I mentioned in the curriculum slide to really be a successful entrepreneur. So I tried to keep my talk to 12 minutes, and I did, and I hope we got a little bit of time for Paul.
Well, good morning, ladies and gentlemen. Before I start, and before my slides come up, I just wanted to comment on one thing that Peter said. You know, I run a small business. I've been doing it for a number of years, probably over 20 years. And without that grit and determination, the ability to fail, I wouldn't be where I am today. And I failed many, many times and have the scars to prove it. The other thing that I would like to point out is the notion of mentoring. Again, I think if I'd had mentors that are available, the types of mentors that are available today, I think by now I'd be on that island with Chief Obasanjo that he was talking about yesterday. You know, I think I'd be doing really well. Anyway, now my slides are up. So preparing engineering leaders for tomorrow. That's a big goal that we're talking about here. What I'm really going to talk about is the kind of the fundamentals of how to get them into a position where they're able to be a leader. I'm really honored to be here. I'm very passionate about the subject. It's what I do. So I could talk for 2 or 3 hours, but I've been given about 15 minutes. I'm going to try and keep it to that. Next slide, please. So I believe we're in the golden age of engineering. If you look at what we think today, we now believe that pretty much anything can be done. Biomedical devices for rehabilitation, support for teleoperation in surgery, autonomous vehicles, drones delivering goods, all of those things, they're possible now. And as Hans said, a lot of this technology didn't exist 5 or 10 years ago, and more technology is coming through. We have this belief that it can happen and things will happen in order to improve society. I'd like to start with this. Sorry, go back a slide. Still go back to the other one. No, before. That one. Still in the golden age of engineering. Because I wanted to bring a sense of optimism. Yesterday, a lot was talking about what needs to happen in Africa, and I agree, and I'll touch on that. But I think we have to be optimistic that the possibilities are here, the technologies are there, and if we collaborate and bring people from all over the world together to solve problems, it can happen. I'm an optimist. I say the glass is half full. I'm not particularly fond of pessimists who say the glass is half empty. But then I was realizing I'm talking to a bunch of engineers. You're very pragmatic, right? You'll just say that the glass was built to the wrong specification. But anyway, think about it. Okay, move on. Next one. So who am I? First of all, before I talk, I'm CEO of a company called Quanta. The name is made up of 2 words, question and answer, which gives you a sense of our DNA. We are designed as a company to supply and support the academic industry, from teaching platforms for undergraduates, fundamentals, to advanced research platforms for research. I'm also a customer of the university system. I'm in kind of a unique position. I get to receive the product from the university. So what we do is we try and bring young people into our company as often as we can to help us develop the solutions and the curriculum and the courseware that make sense to them. And that allows us to be, I think, in the forefront of thinking on how to motivate young students and how to get them engaged. Next slide, please. So a tiny bit about our pedigree. We do a lot of research in robotics, controls, haptics, and we've spent an inordinate amount of money doing that over the years. Many people think we were crazy. But what we've done is we've taken that technology and we brought it into our new products. 70% of the products that we produce today that are going to student labs today were developed in the last 5 years from research we've been doing over the last 10 years. The notion is we're bringing relevant, exciting, modern technology into the classroom and into the lab. Next, please. So what we do is we don't build cars and we don't build industrial robots to sell to universities. What we do is we provide technology which is an abstraction of those things so that you can have a platform that represents, for example, a car suspension, or that represents a robotic system that's not only cost effective, it's also robust and it provides the actual responses that you expect from theory, because it's critically important to have the right theory when you're going into design work. Next, please. But one of our biggest goals is to develop what we call transformational labs. The notion of transformation is moving from one state to another completely, and we want to be able to modernize labs around the world. And these are just 3 examples of labs that schools that we've helped: the University of Sheffield in the UK, York University in Canada, and the University of Incarnate Word in the United States. And we are working with multiple universities around the world, and I'll talk a little bit about a couple of universities that we are talking to here in Nigeria. One of the reasons that I find this so exciting is that I've actually been to these places, before, during, and after, and you see the difference and the change in the profile of not only the students but also the faculty. If you can have an approach which is exciting, and you can see the change in the students, that's a self-fulfilling prophecy. You're going to generate more excitement for the next generation coming through. Next, please. We also spend a lot of time developing forums on areas which are not fully defined. Mechatronics is an area which a lot of people are attempting to teach. In some cases, it's built into the mechanical engineering program. Some cases, it's built into the ECE program. In some schools, it's a separate department. But there seems to be no clear argument as to how to teach it. We don't want to be dictating or determining what that is, but we like to bring people together. This is a conference we held in New York City, New York University. We got 70 professors from 50 or so different universities to come and discuss best practices in mechatronics. Next slide. We've done the same kind of thing in the United States, in Austin, Texas. We've done it in Denmark. We have one coming up in Malaysia, and another one in Dubai took place early this year. Hopefully, in the not-too-distant future, we can do one here in Africa. And I'm talking to people now about developing these in China. The point is, it's my role, it's our company's role to understand how to go about doing this teaching, bringing leaders together and talking about it, and then trying to integrate it into not only our products, but our approach to courseware development. Next, please. So I'm going to change gears a bit. Can I say next? So, why am I here? I'm here because for the last number of years, a lot of friends have said, you should go to Africa and make a difference. Unfortunately, as a small business, I couldn't afford to. I had to get to the point where I could afford to come here and help develop this. So about 2 months ago, I came. I spent some time with my good friend, Dr. Soji over there. I went to 3 universities, Obafemi Awolowo, Afe Babalola, and Covenant University. And look at the students. I don't know if you can see their faces there. We spent some time with them doing some simple demonstrations of the technology we have, and they loved it. It's really exciting. I went back home and I told my wife it's the best trip I've had in 10 years. And the reason it's the best trip I've had in 10 years is because we can make a real difference. And of course, where I come from, when you talk about Nigeria, you hear on the news all the not so good things because the press has a tendency to focus on the negative. I came here and I found what a wonderful bunch of people. I had the great time. The hospitality from Christian, from Professor Soji, and from Abuad, Afe Babalola was amazing. So why is this important? This is important because, if you go to the next slide, if you're going to talk about an engineering shortage and socio-economic development, you've actually got to understand it. So coming to the country, I get a sense that I can feel it. It'll probably take me another 10 years to fully understand, but at least I have a sense. And I got some really good indication from people here that they don't want us to come here and lecture you on how to teach. They want to understand how they can adapt technologies and approaches in an African context to develop students who are employable with leadership skills, with practical skills, with professional skills, and how to develop the capacity to come up with innovation and knowledge for new innovation. Next slide, please. So changing gears a little bit here, I want to give you a sense of kind of where we've come to in our world in terms of the modern engineering worldview. At universities, the core concept should be the physical system. What are you doing? You're making things that do things, whether it be an autonomous vehicle, whether it be an agricultural robot, whether it be a surgical robot, it's a physical system. But in today's world, every single product, every single solution is going to have some level of computation. Built in, they're smart devices, and they're connected to the bigger world. There's got to be some math modeling before you get going in the real world. Devices are modeled and simulated. And you've really got to understand, again, in this day and age, the notion of sensing and measurement. Those are critical importance. So the view of engineering design is encapsulated in this simple diagram. Next, please. So then you have to think about, in a university context, how do you start ensuring that the fundamental engineering themes you teach, whether it's electrical or mechanical or automotive or so on, are built into the applications the students want to be thinking about when they design. And as Peter said, students are coming up with the design ideas. No shortage of them. So if you can put the themes into context with the physical system these days, that's going to make a big difference. Next slide, please. So our approach that seems to be working is the idea of developing, first of all, a context for students. In other words, have students from day one experience the system, final products, final solutions. And in this case, you could use examples of robotics, drones, smart buildings, smart energy, so that when they start talking about or learning their skills, they have some context. And then you move on to the skills development, because as you do that, there's some relevance to what they're doing. The number one question I think that gets asked today for every student, and I've got 3 daughters who are teenagers, early 20s, that just went through high school. The question is why? Why am I learning this? What is the relevance of this mathematical model or this subject that I'm trying to learn? Put it into context, get the system understood from day one. Next slide. When you do this, you're now coupling the tools that you teach with, the methods that you want them to learn to actually develop their solutions, with the vocabulary of engineering. And it's our contention that if you start very early on in a student's life, from day one, using the vocabulary of engineering, then the discussions become more profound. And you can only really do that if you understand what the technology is doing at the system level in the first place. Next slide. So you take that idea and then you start off with discovery. The idea is you're discovering what a system, what a solution looks like, and then you go down the path of exploration. You understand about instrumentation. How do you get information from these devices? And when you get to that point, then you can do the deep dive into the skills development. Whether you want to learn about sensors, whether you want to learn about actuators or so on. Then you analyze how these work in subsystems, simple at first, and getting more complicated as they go through their program. And you analyze it, and then later on, they begin to understand how to integrate those skills into a design. And the goal should really be to get through this process effectively and efficiently. Because the university, for 3 or 4 years, and I hear all the time, we don't have time to do all these other things in our course. There's professional skill development, soft skill development, teamwork, milestones for projects. If you can build in an efficient approach, which allows the students to be motivated during that, you can get those things done quicker, in our humble opinion. Next slide. So wouldn't it be nice if you had an efficient software platform that you could use all the way through university, and you have an efficient ecosystem of devices which you can plug into that framework that allow you to go through the process of learning the skills efficiently and effectively at the point in time when the students need to learn it. In other words, when that subject is relevant to the bigger problem they're trying to solve. Next slide. So we've been working with National Instruments for many years now, and we developed what we believe is a really good skill continuum for things like mechatronics, for automotive engineering, for biomedical engineering, and all of those that require some kind of smart system understanding. Next slide. So with all of that, how can we help? And the answer is simply collaboration. And we believe if we take those ideas that we've espoused, you can start thinking about more. No, go back, please. Go back. You can talk about localized, regionally relevant challenges and solutions, coupled with modern, rigorous engineering design understanding and skills development, with applications that are regionally relevant, and projects that are effective and that include effective and efficient processes. So next slide please, we've called that LEAP, the LEAP approach. So like I said, this is the first time that we've actually worked seriously in Africa, and we're hoping to work with the universities that I mentioned. So what we want to do is we want to work with the advanced methodologies that we've come to learn, and I have the privilege of working all over the world, so I get a good insight into what's happening in many countries. Couple that with the constraints that exist here and the spark. And let me just talk about the spark for a second. I talked to those students that I showed you earlier, and we talked about robotics. We talked about the fact that if there's a global shortage of engineers, they're going to be solving their problems, so you need to develop engineers in Africa to solve solutions here. We talked about robotics, mobile robotics. And they came up with this idea of the potholes. How do you fix the potholes in Nigeria? And believe me, unless you've driven down those roads, you don't fully understand the importance of it. So the idea was you have a robot that runs at nighttime because no one's driving on the roads because it's too dangerous. They drive down the road, identify the potholes, calculate how much material is required to fill the hole, send the message to the truck behind who comes along and fills it up. So there's an automatic, approach to fixing the roads. So that's something which students here would understand. It's something that, where I come from, no one would even consider that as an option. So the notion of a local spark with constraints that exist here, so you can have real innovation for the African context. Next slide, please. The themes that we've been kind of talking about, with the universities we're hoping to work with: energy, electromagnetic systems, IoT, agriculture robotics, advanced manufacturing, and so on. Next slide. And here's just an example of how you can take some of those devices that I showed you for your basic skills, couple them together, and come up with a kind of a lab, a cloud-oriented lab, to make these systems come to life. They give you some imagination. Use the same devices collected together. So now they're beginning to understand the industrial relevance of Industry 4.0, Internet of Things, the reuse of equipment, so that's kind of managing constraints that might exist in terms of cost, and creativity in terms of the way in which they can be plugged together to solve existing problems. And we have a number of examples like this. Next slide. So at the conclusion, I really want to say, we're interested in bringing technologies which are being used around the world, leading edge technologies which excite students from day one, develop the vocabulary, use system-level software throughout the course. And I want to talk just very briefly on the fact that we've been working for like the last 3 or 4 years developing a mobile platform as well that allows modules and content to be included on mobile devices. We're doing a little experiment here in Covenant University, and in just a few weeks, 2 or 3 of the students here have already developed some apps, which is really exciting. It's a platform, next slide please. It's a platform which allows rapid development the rapid development of applications for teaching STEM subjects, and I think it's going to make a big difference to the motivational side and the excitement the young students have with engineering. Next slide, please. I'm going to finish this with this slide, and like I said, this is a subject which I live and breathe every day of the week, and I travel the world with. And we did a survey of our customers, our partners around the world, and we're very proud of the fact that the thing that stood out was they view Quanta as colleagues as opposed to vendors. And I hope over the next few hours while I'm still here, and over the next few years as I come back to visit Africa, I'll get to know a lot more of you, because it's a very exciting time. And I want to share with you my sense of optimism that with this group of people, over the next few years, some significant steps can be made. Thank you very much.
Thank you. I know we've been getting all the information in the course of this plenary session. When we're continuing, we now had our M tutor, who is very much here with us, Mr. B. Senthilkuma. I hope I'm correct. I would like to welcome him now for his presentation. M tutor.
Good morning, ladies and gentlemen. Good morning. Thank you so much. It's such an honor and pleasure to be a part of this summit. I express my heartfelt thanks to the Aedc President, Dr. Obiazi, for giving us the invitation to be a part of this summit. And I also thank Dean for all the help to getting us here. So the last 2 days, I was able to kind of network and speak to people and share what MTDA does. So most of you know the crux of what we do, but I'm just going to take you through what we do in detail today. So I bring in a lot of greetings from my fellow colleagues in India. We're very excited to do business in Africa. So we started our Africa Presents in the year 2015 when the AEDC Summit actually happened in Ethiopia. Since then, that was a great platform for us to showcase the solution that we could offer to the prevailing challenges which is out here like we have in India as well. mTutor is basically a digital tutorial tool which supplements engineering education, higher education, engineering, applied sciences, polytechnics, humanities, or some of the platforms, some of the streams that we support. So we began with engineering. The reason being, India produces most number of engineers every year. Closely about 1.5 million engineers we produce every year, and most of these people go unemployed, not getting into a stream of engineering, but get settled with some basic jobs. It's primarily because these students who pursue engineering does pursue without fundamental knowledge on maths and science and still go on to pursue engineering. And there are a lot of social pressure in India, to do engineering. When you do engineering, there's a lot of other benefits you get when you grow up. You get married, you be an engineer in India, you get married, you have a lot of benefits coming from the groom's family. So engineering is looked at great for them, and hence corporates, enterprises who want to recruit engineers fail to pick up the best of engineers because these people lack fundamental skills. So we did research and development about such a scenario prevailing in other nations as well, and we found sustainable interest, passion of pursuing engineering is always a challenge across the nations that we are working on right now. So what we thought, we would give them a supplement tool where learning engineering becomes a passion. So what do? So we thought we make learning engineering is fun. So we introduced a pocket classroom which works on browser, which works on a mobile application, and most of these people are hooked onto phones these days all the time. So we thought we'll give them the courseware on a mobile device. So what we do is we work closely with institutions, take the curriculum, tailor make the syllabi, break it down to small lesson plans, and give them as capsules or small videos which run for about 15 minutes. Each topic runs for about 15 minutes basically, and these videos are basically interactive. So every 3 minutes, the session engages the student to answer questions before you proceeds with the video. So this comes not just with videos, but also with a lot of value attributes, like a lot of features, like you can instantly get with a chat facility with the faculty. You can raise a doubt. You have question banks for ready references. Then you have assessments. People can self-evaluate themselves and find out where they are basically on each topic on each module. So even before I run the presentation, I would run a video and show you how this video work. Basically, this is basically an offline video which may not have all the features on which is available on an online forum. Let's take a mechanical subject and
Archers and gears in tractors. At the end of this lesson, you will be able to explain its different types used in tractors. Rajput, a farmer, loaded his tractor with vegetables. He has to hurry as he started late due to bad weather. He must transport the vegetables to a neighboring city in hilly regions with the help of his tractor. Being late, he wanted to reach his destination as fast as he could. So, he increased the speed of his tractor. In other words, he changed gears gradually from the first gear to the second gear and so on until he reached the top gear. However, on his way up the hill, he suddenly reduced the tractor to second gear from top gear to climb the hill. Why did he do that? Even though he was in a hurry, he reduced the speed of his tractor while driving up the hilly region. What could be the reason? We know that the tractor has to pull more weight when it is climbing hill regions. But why is there a reduction in speed? To know the reason behind this, let us see a small experiment. Consider a small gear is attached to a rotating shaft, which in turn is connected with a rack arrangement that is used to lift a load or a weight. If we increase the load, the rack arrangement may not be able to lift the load with the same shaft power. Let us make a small change in the gear arrangement. Let us attach the small gear with a larger gear and make it as a compound gear. Connect this setup in the same shaft to the inner gear and connect it into another larger gear. Now, if we try, this arrangement can lift the larger weight or load. This shows that when speed is reduced by connecting a larger gear, additional load can be lifted. Similarly, a vehicle pulls more load while going in an uphill road comparing to the load in the plain road. Rajput reduced the gear for this same reason. Let us see what happens when he reduces the gear. The smaller gear in the driving shaft will be meshed with the larger gear of the lay shaft. This arrangement is similar to the experiment we saw. In this way, Rajput reduced the speed of the tractor to increase the pulling capacity of the vehicle while going uphill. Thus, the function of a gear is to increase the vehicle's speed, which in turn reduces the torque as well as reduce the vehicle's speed to increase the torque according to the loading conditions. The set of gears enclosed in a casing is called as gearbox. In tractors, two types of gearbox can be used. They are sliding mesh gearbox and constant mesh gearbox. The gear arrangement
the video goes on like this.
A sliding type because here the gear slides.
So I'll play one more video that we have done for a vocational group in Delta State. Can we play that video? So this video had an Indian accent. The one that we are getting it done for one of these institutions in Delta State, will have the local accent here.
Define automobile workshop, identify the automobile tools and equipment, describe the general maintenance of an automobile in an automobile workshop. General automobile maintenance. Automobile workshop is a place where the automobiles are served for maintenance and repair works using the auto mechanics. Let us first understand the term maintenance and repair. Maintenance. It is a vehicle service carried out after a set time interval or after the vehicle has traveled a certain distance. Repairs. It is also used as a breakdown maintenance where the maintenance is carried out after the failure occurs. In order to perform the maintenance and repair works, certain tools and equipment are used. There are ratchets and socket, tongue and ratchet.
Thank you.
Screwdriver, pliers.
So this is basically done for a vocational training group in Delta State. So what M-Tutor does is basically a pocket classroom which takes learning beyond classroom. This application-oriented a training tool which explains conceptually and contextually for people to understand the fundamentals better and start performing. Usually the pattern of students learning is exam-centric, it's not knowledge-centric. So this tool helps them to understand the fundamentals and get to acquire knowledge than looking scoring marks. So since we have introduced M-Tutor the last 3 years, we have penetrated with about 40 universities across India, which includes NITs, large National Institute of Technology, to be eminent universities in the Indian market. We work with about 9 universities in India. And we also work with the top majors within India, and we also work in the Middle East market. In Africa, to be specific, we work with Cameroon, we work with St. Jerome University, and we also work with 8 institutions in Uganda. And recently we signed with the Delta State government to implement M-Tutor mode of learning for all the vocational and polytechnic institutions. So what this product offers is animated tutorials, easy to understand the concepts. We also offer local language support. This gives you a stepwise approach for people to understand concepts better, and you can measure the learning outcomes. Basically, the tool is inbuilt with analytical engine behind. So an institution would be able to estimate and understand what kind of a timeline a student spends on learning through M-Tutor, and what are the scores he secures using the assessment module in M-Tutor. And it also has social learning advantages, where you can connect with a peer from another university, you can talk to a faculty, you can raise doubts, and the doubts which are answered, comes through an SMS alert on his smartphone, so that he can log in and check out his answers. So he need not wait only during the campus time, but he can continue his learning beyond the campus hours. So this creates a lot of passion among students. See, we have understood that significantly it has given a 15 to 25% increase on the core subjects. People who are securing marks, have given a great increase. Exposure to conceptual and contextual learning, and it bridges the gap, between the faculty and the student. The student becomes, more interactive in the class, and usually people shy away, in the class, fearing, not knowing the subject, or giving, wrong answers. So people, assess themselves during these sessions. They come prepared, watching these videos, and the synergy between the faculty and the student increases after using M-Tutor. And for teachers, for institutions, this becomes a learning tool basically. In most of the institutions that we work with, use it as a blended learning tool, where they play the video in the classroom, and then the lectures happen after the video gets over. So the teachers also get involved with us in terms of curriculum development and all that. So it makes life so easy for both of us to give what the student want, pertaining to that particular institution. So the institution gets a unified platform, for them to connect. They deal with students, and the faculties can have different credentials, and the institutions can also evaluate the faculty through this tool. And so there's a lot of monitoring reports gets generated out of this. And we are also bringing in the industry inside this, so this becomes another avenue for industries, to look at this as a recruitment tool, because there are closely about almost about 1 million engineers use this product across the globe. We also work in the Sri Lankan, Bangladesh market through the telco VAS operators. So the enterprises gets an opportunity to have access to the entire database of the students who use the product. After the launch of the product had gone ahead and won the best education app from India, which was conducted by Telenor Group in Norway. And that's the email that we have got from the CEO of Telenor, stating that we've won the best education app in India. And these are some of the press releases the institutions have launched. You can see one Delta State government partners with an Indian firm on vocational education. So these are a few of the testimonials. So as I mentioned, next slides. Institutions who use M-Tutor have seen a dramatic increase in scores in mathematics and the core science subjects. So we wish this product could definitely add to the school of thoughts of all assembled here, to bring in a a great change, a transformation to the African market. So we would definitely, as an organization, promise to stand on the forefront, to partner with all the institutions out here and see how best we can collaborate and, make learning, really meaningful, and which gives a outcome-based learning. Bottom line, we need to find students skillful and employable. So we definitely hope MTutor can be a tool to the African region to help students attain their objective, and we're definitely looking at partnering with institutions out here. So we welcome you to post your questions to us through an email. You can call us for a pilot. We can do a pilot in your institution. We can implement MTutor for some time, and you can evaluate and see how does it help, and then possibly from there we can take it forward. So thank you so much for all your time. I really appreciate that, Dr. Obiazi, for all the support. Thank you.
Thank you, MTutor, all the way from India. Thank you very much. We're going to be breaking into into technical sessions. After this, I'll be calling on the LOC chair for an announcement. But we're going to be breaking into concurrent technical sessions. And we have 3 sessions. If you look at our program on page 20 and page 21, page 20 and 21, you'll see those concurrent technical sessions there. And they are vertically taken, not horizontally. For example, session 1 will be the first vertical, the next session just like that. So you are looking at the columns, not the arrow, not the what is it now? Rows, not rows now. I still remember my mathematics. We are looking at the columns, not the rows. So for the first session, we're going to be dealing with energy sufficiency and sustainability. And the chair for that session, which will be taking place in this main ball, this auditorium, right where we are now, that will be for session 1. Professor Aedc, I hope I'm correct, from Elizade University will be the chair for that session. Then the second session will be upstairs, where we met yesterday, upstairs. And the chair for that session, all the way from Kwame Nkrumah University of Science and Technology, Professor Boateng, will be the chair for that session, Professor Boateng. Then the third session, our ushers are there to direct us. As we move through the foyer, there's a corner by the left there, by the media hall. That will be where we'll be having the third session. And that will be taken by Professor Henry, that is there, from Makerere University. I hope I'm correct, sir. Yes, all the way from Uganda. That will be for session 3. And that will be on engineering and efficient healthcare delivery. For session 2, engineering training for global competitiveness. And if you check as we move along, there are other sub-themes that are going to be there. Like we have creating gender balance in engineering education, still in session 1. Session 2, sustainable water and sanitation engineering. And then session 3, engineering, entrepreneurship, and skill development. I want to believe our rapporteurs are taking note of what we're doing, because subsequently we'll be calling on the chief rapporteur to come and let us into what has been happening since this summit commenced. At this point, I would like to welcome the LOC chair, Professor Christian Bolu, for another information. But we are told for persons who may want to travel now that there's a bus waiting out there who have a flight that is very close by. And for subsequent flight arrangement, Professor Samuel
Working with Bells, we're taking up the project of Yakub together. We'll take it together, get engineering students, and we'll develop together. Let's see if this can start from this conference. 3 minimum. Get 3 universities that are not yours and take a project. We've got about 3 projects that have been announced. M-Tutor is there. Kwanzaa said something. Yakuba said something. Otherwise, any other thing. Please, we would like to have this feedback so that in the 4th summit, we can say, give the kind of the way Yakub was giving the testimony of this collaboration that it has started. At least 3. If you don't do 3, then you've not done well. If you want to see M-Tutor, please book with him. He's already doing something with Covenant University. We're doing something with Kwanzaa. So you please see them now, book your appointment with them, and see that you take advantage of this. I'm sure there will be discounts if you book them from this summit. We will negotiate for Aedc so that they can also, they're already sponsoring us anyway, so they've given us the discount already. Please enjoy this day. Do not go, please. Do not go. These last few sessions are here. The most important thing, there'll be an AGM. AGM, that's where we round up all this only for members, for only deans, right? President, are you here? Okay, Henry. Okay, you're here. It's only for deans, is it not? Any deans, and anybody who has been a dean before. Once you're a dean, you're always a dean. So if you've been a dean before, you must come for this meeting. We will be looking at the Constitution, and also we'll be reading we have the first reading of the MOU we would like to sign with Koren and the Man. That is the deliverable we expect to have from this conference. So we'll be reading that. It will go through the first reading, and then everybody can make comments. Then a set of committee will go and work on it before it's executed, and then we start working. Thank you very much. Please, can we go to our locations? I think the first group is here, second group is there, and the third group is up there. Lunch is walking lunch. Around from 12, you can go out, take your lunch, eat, go back until 1 o'clock when we close this session. Thank you very much. I would like to see Abagale, Professor Lormaye. Professor Lormaye. Yeah. Okay, yeah, there, sir. The president, there's a room, they've given us a room for the draft. Any of the VCs who feels will want to join us, join.
I want to see Prof.
Okay. Okay.
So I can at the back. At the back, the same building.
This building just at the back. The library. We see library. I'll open it up. I'll leave it open.